At least it looks like it, you know. It's like, oh, I think I've seen this movie before. 1996. So you were 37? 37, yes. I was like, me too. Yeah, me too. I know you said that just yeah. It's like I remember. It's 20. Today is 20.
You need water? You need water?
No, I still have water.
Good, you good?
Thank you.
It's your legacy of the IPM league. I love this place. It's frustrating that it can be sometimes, but I love this place.
Do I have the bananas?
Aaron, how behind your feelings? Then you can just leave the messages out of your email archive and say, hit resend.
We officially started 2 minutes ago. Let's see, so did you pass out the blue sheets already?
Yes.
Yeah.
Who?
They are.
Oh, okay.
Yeah. Getting old experiences. The short ones? Yeah.
I'm the chairman of these meetings. I can't remember what the heck we did the last time. We are Kensville. Yep. Kensville area of the map. Excellent. So I'll take these.
And the discussion about how to
So we will be starting in just a couple minutes. Maria is opening tabs, and I'm passing out the blue sheets. While I'm walking down and walking back up, we did have one volunteer of a scribe, the lovely Matt Ford, and a volunteer of a Jabber monitor, the lovely Aaron Falk. We need one more lovely scribe. You can start hoping we don't call on you.
Yeah, while Spencer's walking down there, I can probably already start and welcome you to the TSV area meeting. We have a rather light agenda today. And why is this not displaying correct anymore? Because I want to press here, I guess. Okay. As always, I would like to show you the node well. I hope you have seen this already. You know what's about it, and it still applies. Yeah, that was the light agenda I've been talking about. We have the usual stuff. We have blue sheets already, Java scribes. We're doing the agenda blessing right now, so you have a chance to comment on that. We have one BOF announcement. It's not a TSV BOF, but it's related to TSV topics, so that might be interesting for you, which takes place tomorrow, I believe. We have Tom Herbert, who will report on the Linux NetDev conference, so that's relevant to transport topics, and I'm happy that he's here to report on it. That's, I believe, the third NetDev conference they had, and they usually have a lot of topics that are interesting for us as well. And then we have a lot of discussion time on the end to continue the discussion on transition strategies we just started the last time in, where have we been?
Berlin.
Berlin.
We were in Berlin. I have an alibi.
We would like to thank our review team, which is getting up to speed a little bit. You see that the number of reviews we've seen since the last meeting, so that's not kind of equally distributed, and we would like to change that. That's not a general problem because we hope to see more reviews in future anyway. We're trying to speed up everything here. But if you see your name up there, try to volunteer for reviews. And kind of that's the status of our working groups. We have, let's say, around 10 active working groups, a little bit more. And there's also the status update in the data tracker. We've been sending reminders to our chairs to ask them to put a status in the data tracker before every meeting, basically, and a lot of the chairs are doing this by now. We hope that this will help to track the process of the working group. It will help inform people who participate in the working group to understand what the working group currently is doing, where the status is, but it also helps us to have a little bit of feedback from the chairs, so thank you for that. And you can, and there's a link here, so you can click on it and even look at all the reports from all the working groups. Should I go through it one by one? You want to?
I think, like I said, I think it's worth mentioning. We closed 3, I think, working groups as Martin was stepping down and Miria was stepping up back in the spring. We've had some BOF since then. We've chartered 1 working group, so we're probably in the upswing part of the activity cycle for us.
Do you want to go one by one? Do you want to go one by one?
I think if you have anything to say on a particular one, sure.
Yeah, I would like to welcome 2 new chairs. That's Colin Perkins and Michael Jackson.
Thank you for serving the community in this way.
And actually also the 2 quick chairs are new chairs, of course. So that's Mark Nottingham and Lars Eckert. And Quick had already the first meeting, and they will have an interim in January. That's maybe something to announce. Other than that, yeah.
Let's see, anything else I needed to say? Doesn't look like it. Thank you. So this is a little bit lighter than our last one, which is not surprising since we had the summer month of, August and half of September in there, basically. But we did get it out an awful lot, and probably the biggest thing that's popped out, the biggest chunk of things that have popped out have been NFSV 4.2. So this is like a major achievement for the NFSV 4 working group. Other notable events would include GRE and UDP encapsulation, 5405 BIS, and were there any ones that you wanted to call it for special joy?
I mean, yeah, I can maybe. So there's from the AQM working group. There's 1 more document in the pipe, and then basically the AQM working group is also done.
We love having document names and RFC numbers on this slide. I'm just saying, and we do update it every IETF now.
So I used to have 1 slide on L4S. I think that disappeared. I'm not sure what happened to it. Should I say something about L4S?
Oh yeah, absolutely.
What happened to that slide?
It was delicious.
I just realized that we lost the slide. So I will simply tell you what was on the slide without having the slide. I wanted to say a few words about L4S just to avoid any further confusion. So there was a non-working group forming BOF at the last meeting, which was very successful, very positive feedback, very much support from the community on doing this work. But there will be no own working group because it's really very related to the work we are doing in two existing working groups. One is TCPM and one is Tsvarea. So all the documents which have the L4S acronym in their name go in one of those two working groups, and the split is pretty simple. Everything that's directly related to TCP goes into TCPM, and everything else goes in TSW working group. Just to let you know that that's what's happening here. I think we already had the TSW working group meeting 2 days ago, yesterday. When was it? I don't know.
Don't go home. It's hard to remember.
And there was support for this work, so I think this approach can work very well.
David Black, TSV, one of the TSVWG working group chairs. Gory's in absentia coming over RTC Web. Yeah. There's sense the room to adopt the docs. We need to adopt an ECN experimentation draft first to clear the way for what L4S wants to do. But the three main L4S docs, the architecture, the AQM, the queue management algorithm, and the use of ECN are going to be TSVWG drafts. So got 3 out, at least 3 more inbound.
David, could you stay here for just a second? Were there people, if you could raise your hand if you were not in TSVWG when those drafts were discussed? Cool, then everybody should know what's going on.
Okay.
Thank you.
Yeah, and Brian, you can come up.
Yeah,
Or is it Margaret who's presenting? I'm
oh,
not sure.
both of you,
Sorry,
please.
yeah, cool.
Yeah.
Yeah, you can even both come up, yeah.
This is one of the exciting ones where you have people doing work on the edge between 2 areas. So we have folks from 2 areas that are clearing the buff.
Haven't been in this big room.
Do they have the pink square down there?
Yeah, they do.
Oh, okay. The rest of the floor is electrified once you start talking.
So, as the chairs mentioned, we're going to be having a BOF tomorrow afternoon. It's called the Banana BOF. Banana stands for Bandwidth Aggregation for Network Access. And basically, this is a BOF to discuss a problem space and some solution work that's been done in that space, where you have a home network over there on the left. You have your host and your CPE, and you actually have more than one connection to the internet. So maybe DSL and satellite, or cable and DSL, or DSL and LTE, or any combination of connections to the internet. Could be more than 2. And you want to have some way to use that bandwidth, right? And right now, a host will generally have a notion of its default gateway. It's going to send traffic through one of those CPEs, and that link will be used, and the other link will not be used, okay? In the home in particular, this is an interesting case because this isn't about like traffic engineering in the internet or in a large carrier network. In the home, there may be only a few flows, a very small number of flows. And so we're looking at how can we share a single flow or a very small number of flows over a small number of paths coming into and out of the home. And so that's our topic. And it's specifically for the case where you are on a multi-access network, but the hosts themselves, being current, Macs, window boxes, et cetera, are not multi-access aware. So they don't have, we're not going to put some sort of solution in the hosts to do this. We're going to want to do it within the network somewhere. So next slide.
I think
there were 2 when I saw them. Space sometimes does it. We haven't discussed that yet. The solutions that we're doing, actually combine them. I mean, at least one of the solutions combines them potentially because it's a tunneling solution. There's also, if I could get to the next slide, here we go. We're going to discuss that problem, and we're also going to discuss some points in the solution space that have been brought up in various discussions we've had bar-offs before this. One of them is a GRE tunnel bonding solution, and that basically uses GRE tunnels to split the traffic and recombine it on the other side. We're going to look at an MPTCP proxy solution, which basically uses MPTCP at least to multipath the TCP traffic and then proxies it back somewhere in the network. And then we're also going to look at a bare UDP experiment that Mary Ann Bryan worked on and talk about learnings from that might apply to this problem. We're going to discuss coordination with other SDOs. The BBF has a much more limited scope problem statement in this space, where they actually assume that the multi-access links are all from the same provider. For instance, LTE and DSL, I think, in fact, explicitly LTE and DSL. And they're going to actually combine that traffic inside the provider network. And we're also going to basically discuss how the IETF wants to go forward in this area at all. This is not explicitly a working group forming BOF. We don't have a proposed charter. We're going to talk about whether we think it makes sense for the IETF to do work in this area, and if so, what sort of work, and may decide that we want to charter a working group, do work in other working groups, come back and have another BOF. We don't know. So we would like it if you all came tomorrow and helped us figure that out, 1:30. I think the previous slide said where, but Park Ballroom 1 at 1:30. Thank you.
Thank you for being here, Margaret.
I mean, any question, but we don't want to run the BOF now, so probably wait with questions for
Margaret, could you slide that back down on the stand there? Thank you.
So it is listed in the BOF wiki with readings and an agenda and everything. So if you have questions, they're probably answered there. If they're not, bring them to the BOF.
And thank you so much.
Thank you. So Tom, you're next.
Hi, my name is Tom Herbert, and I'm going to give an update on NetDev. This is a Linux conference for networking in particular. So we had the conference last month in Tokyo. I guess that's kind of close. We had about 200 developers attend. Next one will be in March 2017 in Montreal. This time around, we had quite a few papers across various networking topics. Websites there if you're interested in more details. So some highlights. One of the more interesting things was BBR. This was also presented yesterday in ICCRG. This is a new congestion control algorithm being developed by the folks at Google. It's basically trying to find the optimal point of data going into the network versus bandwidth and RTT. So there's a nice algorithm that they've implemented to find this point. They put this into the kernel. Apparently they've been running it for quite a bit. They had some very nice results on B4. A few questions did come up, particularly in the interaction with BBR and Cubic and some of the other congestion control algorithms. Another one that got quite a bit of interest was XDP. This is Express Data Path. What this is kind of a high-performance data path that we implemented in Linux. The idea is to put code directly into device drivers to process packets. So one of the things that we noticed about Linux, especially with respect to what some of the user space bypass folks were saying about performance, was the Linux stack is slow. So it's slow because it went through a lot of layers and it's very generic. So what we can do is we can eliminate that, put this snippet of code down into the driver and get very good performance results. So not only that, we also made it programmable. So we're using BPF, Berkeley Packet Filter, as a programming language to do filtering and to do packet transform, packet forwarding. So the story there was we got this into the kernel. We have right now, I think, 3 driver vendors that are supporting this, or 3 device vendors. There's also a component here where we want to offload this into NICs to do a programmable NIC implementation. Next slide. Hardware offloads continues to be an area of a lot of interest, particularly in the virtualization area and programmability. SwitchDev is an effort to basically offload a switch from Linux, a full switch capability. OpenMPU, more on networking processors. There was quite a bit on accelerating containers and network virtualization in general. I mentioned XDP, and kind of separate from that, but related, it was eBPF offload. Another instance of the virtualization offload was the Tsvarea V implementation for virtual or Open vSwitch. And the Mellanox folks are actually trying to figure out how to offload TLS in a NIC. They presented the transmit side, which seemed pretty reasonable. Receive side, I think there's still a bit of skepticism. It's a much harder problem, but transmit side actually looks pretty good at this point. A few more highlights. IPv6 segment routing. These patches were actually, at that point, being proposed and reviewed. I believe they've been accepted. These were really good work by David LeBron, and they went in a very clean way, so we're excited about that. As I mentioned, there was quite a bit of discussion on kernel bypass, user space transport stacks. Dave Miller's keynote, in fact, was basically on what does running a user space stack like Quick or Tau, what does that mean in terms of impact on the kernel and impact on kind of the safetiness of networking. And one of the things the kernel provides you, obviously, is some restrictions on security and things like that. How are these going to be enforced in user space stacks? A little bit of discussion on that. Dave Watson from Facebook gave a presentation on kernel TLS implementation. So the idea here was to move TLS into the kernel, and this allows things like splice, send file, to actually use TLS without going to user space. So we see a big performance improvement with that. We had another discussion on encapsulation offloads. This topic has been coming up for about 2 years now, and we've gone through several iterations. So the backstory is we obviously have a lot of encapsulation protocols, particularly encaps over UDP coming into IETF coming into the kernel. And with these, we want to support basic offloads like checksum, RSS, and things like that, generic send offload, receive offload. So we've actually done quite a bit of work, and I think we're pretty proud of how far this has gone. But where we want to get to is basically have the kernel and devices be able to support any encapsulation kind of in a generic way, and do this without requiring hardware-specific offloads. This really gets us into how to solve protocol ossification, or at least one form of it. So Alexander Dyack presented the state of this with UDP. There's actually been quite a lot of work. One of the interesting things, for instance, is we used to worry about checksum and calculating UDP checksum and whether or not an encapsulation packet, if you had 2 checksums, do we need the hardware to compute 2 different checksums? It turns out we now have figured all that out, and we only need 1 checksum offload, can offload an arbitrary number of checksums in a packet. ILA, we touched a little bit on. This is identifier locator addressing. This actually was fully upstream, so we mentioned a little bit about the checksum neutral implementation. I'll actually be talking about this later on in Interia today. And virtual routing and forwarding. So these patches actually have been in Linux for a while. David Ahern was actually given some clarifications and some extensions to that, which is very compelling. Next slide. So I guess that's it. Any questions? Okay.
Yeah, thank you very much for bringing that.
Can I ask a very quick question? Is there a chance, because it will be in March in Montreal, the next meeting, right? And I guess the dates are not decided yet. The next meeting will be in March in Montreal.
Next meeting is in Montreal in 2017. There's a NetDev 1, I think it's 2.1 website is what we're calling it this time. March.
So,
Yeah, I have alerted them to this fact, synchronizing this. So they want to have that conference twice a year. So we'll try to avoid IETF if possible. But IETF obviously 3 times a year, so we have a little bit of a problem there.
Tom, you did a question on the Jabber asking about what is XDP offload. Do you think maybe you could provide a reference or maybe an expansion?
For more information on XDP, I would suggest look at iovisor.org, I believe, is where a lot of the development has been happening. There is some documentation in the Linux docs, I believe. We also have quite a bit of documentation on the BPF side. We haven't actually organized all the XDP documentation yet. I think that's still an outstanding task that we're going to have to do.
Just Bob Briscoe, just to say, I think part of the thing about the dates wasn't just avoiding the IETF, it was maybe getting the week beside it so that people don't have to fly back and forth across oceans.
Okay, we'll pin that down as soon as we can.
Thank you very much, Tom.
where's my mouse? Brian is next. Brian? Yep.
Okay, Brian, you're up. And thank you for being here.
I am Dave Thaler. I am Brian Trammell. Dave couldn't be here today. He's got he had to go sit in HomeNet for some reason. So this is actually a replay of Dave's presentation in Berlin. Who is in here who was not at Tsvarea in Berlin? Okay, okay, cool. Worth going through.
About half for the remote
About
folks.
half, yeah. So this is a document that's it's an IAB document about how you can, in designing protocols, plan for transitions within those protocols. Dave did this presentation at Tsvarea in Berlin, and we had like 3 seconds for discussion afterward, and there was a discussion going. So we wanted to actually redo this and then restart that discussion, specifically with respect to a lot of the stuff that's going on in Tsvarea right now. This is a very high transition area in the IETF at the moment. Slide. So there's different kinds of transitions. This document focuses on transitions in protocol transitions. We're not talking about organizational transitions or political transitions. We're talking about transitions within protocols developed and deployed in the internet. Next slide. Some of these principles come from RFC 5218. Who's read RFC 5218? What makes a successful protocol?
It's actually a quick read, and it's actually very good.
Next time we do this talk in Chicago, I'd like to see more hands.
Next time we do this talk in Chicago, I would like to hear people talking about how their protocols are going to be transitioning.
Great. So there's a few principles that we took in this document from 5218. These are all relatively obvious, I think. You need some incentive to deploy a protocol in order to transition from one deployed protocol to another deployed protocol. It's much easier when early adopters have an independent incentive to deploy. It's much harder when you need to coordinate deployment because nobody necessarily has an incentive to go first. You need to be able to incrementally deploy. You can't really do flag days anymore in a network as large as the internet. This is easiest when there's only one entity that needs to change in order to get benefit. This is the difference between trying to think of one of the easy to change on only one end.
TCP.
What?
TCP.
TCP. Well, I mean, you can change, use congestion control protocols on the sender much easier to do than something like MPTCP, which needs both endpoints, much easier to do than something like ECN, which needs both endpoints and the middle. There's a notion of total cost that that you should pay attention to. It's not just looking at the cost of the change in one particular code base, but in all of the code bases and in all of the operations and management that goes along with it. You need to look at accounting, billing, legal. And one way to make transition easier is that you can design for extensibility in the first place. Although we've also had lessons that if you design extensibility in the wrong way, it can even be more dangerous than not designing extensibility in at all. Next. So when you're looking at the cost and the benefit, there's a couple of types of curves that you see here. This one on the I guess that's your right, is sort of an independent deployment sort of cost-benefit curve. There's the benefit has to be above the cost, otherwise it's not going to happen. But as time goes on, that cost-benefit relationship doesn't really change because you can deploy it independently and you get sort of the same effect. Maybe it works a little bit better if other people are using it too. But so, for example, again, TCP congestion control deployments would tend to follow this. Graph B is what happens when you have network effects, where you need to have either a greater number of endpoints and or support in the network in order to get the transition to happen. And here it's a little dicier because everybody who is making the transition on the left side of that inflection point is basically paying more right now for a thing that there's a risk might not happen. So the IAB held in 2013, I think it was, Internet Technology Transition Workshop. The report in that is RFC 7305. There are a couple of observations there. One, it's easier to sort of take one of these curves on the right side, so one of these network effect curves, and get people to pay in if you have some sort of additional incentive for early adopters. Bitcoin is listed here, but basically every cryptocurrency has this. It's like, come and join us now and you will be one of the ones who gets rich. And also, so especially when you're talking about larger, more wide-ranging changes, having friends in the policy space can help as well. So especially so with respect to the transition of IPv6, that obviously could not have been done without the RIRs. Anything that touches the DNS cannot be done without ICANN, so on and so forth. So again, when you talk about transition, often it's like, oh, we have this old and busted thing, and we have this other thing over here, which is new and shiny, and obviously everyone should be running the new shiny thing. If you have backwards compatibility, you're basically planning for, okay, well, everybody can use the new thing and the old thing, and we don't really care. They interoperate very nicely with each other. There's no significant difference, and then you're going to have coexistence for some time because the people who have the incentive to change the new shiny thing are going to do it. The people who don't are just going to keep running what they've been running. It gets a little bit harder when you don't have backwards compatibility. The canonical example, I assume people in here have heard of IPv6. The canonical example is the IPv6 transition, where you either need a direct transition where there's an idea that there's going to be a replacement, or you need a plan for coexistence. I think that sort of...
Did you just call IPv6 new and shiny?
Yes, new and shiny.
We're not going to take a hum on that.
So I think the original plan there was that IPv6 was going to be a relatively quick transition, and now essentially we are in a indefinite overlap period, and have sort of changed the transition plan on the fly to go from this transition-based transition plan to this indefinite overlap transition plan. There are a few downsides to this, as we've learned with IPv6. One is that coexistence increases costs, because pretty much we're going to be on a dual stack internet forever. And then if there's a really, really long overlap period, you're going to have people who are going to say, well, why do I have to be one of the other ones to join into the overlap? So all of these things are things that are in play in IPv6. So one of the things we learned from that is if you actually are going to partake of one of these transitions, you should probably have a plan. You should plan for some period of overlap, and you should have an idea of how you want to get out of it. If you don't have interoperable systems, then you need a translation or adaptation layer, or in the case of IPv4 and IPv6, you need 24 of them. Translation in the middle of the path can hamper end-to-end. Translation at the end can be a resource issue in a constrained node. These are all issues that we're talking about in MPTCP right now, right? When you have, and we'll be talking about as well in the banana BOF, where you have network attached devices that are more likely to be sort of things on the path that are more likely to understand that they are multipath connected than the end devices are. So if you're going to have a non-backward compatible mechanism, you need to have a discussion of where it's placed, why it's placed, and again, how you're going to transition out of that scenario. So what makes for a good transition plan? These are 6 points. These were 4 points before TSV area in Berlin. 2 of them were added since then, the ones that are in italic. Otherwise, these were exactly the same slides. So you need an explanation of incentives for each entity involved. You need to basically say, here's why you would deploy it at an endpoint. If it has some sort of interaction with middle boxes, you need to explain what's in it for the middle box deployer. You should have a description of phases. Okay, we're going to, here's what happens when just the endpoints deploy it. Here's what happens, or just one endpoint. Here's what happens when you have it on both sides. Here's what happens when you have awareness of it in the middle, so on and so forth. It'd be really, really nice to have a timeline. I think the timelines that we would do in transition plans in the IETF would probably be about as optimistic as the milestones that we do for working group planning in the IETF. But it's good to have one anyway so that you can see how late you are. You need a way to measure whether the transition is succeeding or not. So actually, that was really interesting. There was just a thing that was going around on Twitter. So I think Dan Wing and Bipal just put out some numbers showing a gigantic spike in Alexa websites that are reachable via their Quad A records. That's almost doubled in the past 3 months. And that's what happens when a large CDN decides to turn it on by default.
Wow.
So there you can actually, if you weren't like actually running these measurements, you wouldn't know, and you weren't that CDN, you wouldn't know that that had happened. You need a contingency plan in case something goes wrong. That would be really, I mean, this is blue sky thinking, I think, in transition planning. It's like, okay, well, I'll go back to IPv4 and we'll use NATs. That'll work.
Brian?
Yeah.
When you all talk about this, are you talking about what we will do if something doesn't work, or are you also talking about what a particular implementation will do when the new thing doesn't work?
That's a really good question. I think we mean both. I mean, when we talked about this in Berlin, we didn't really dive into that question, but I think we mean both there, right?
This is why we brought you back.
So yeah,
I think maybe the second one, because I remember us calling it failover.
Failover or fallback.
What we were talking about. Well, yeah, fallback. I'm sorry. It's Wednesday, but I'm thinking the more I'm thinking about it, definitely 2 different things. Both interesting. Yep. Thank you.
Yep. So right. I mean, like so the outer control loop, right? Like, so what happens in sort of our processes as engineers is, okay, well, you notice that transition isn't succeeding, and you need to say, okay, well, do we need to do other engineering? Looking at sort of the history of IPv6 to IPv4 transition technologies, it was like, we're going to try this, oh, that doesn't work. We're going to try this, oh, that doesn't work. We're going to try this, oh, that doesn't work. And each of those were sort of reactive as opposed to proactive contingency plans. The second thing is that a lot of the engineering that's happened in the past 20 years has happened on the backdrop of Moore's law, which means that where we actually did need to have the engineer in the loop before you can actually automate some of this stuff. And that's how you've gone from contingency planning in terms of, okay, we need to change the bit pattern on the wire, to contingency planning in terms of the endpoint itself can do the measurement necessary to determine if this is working and then change the bit pattern on the wire. And then you need a way to communicate a plan to entities affected and incorporate feedback. And for things that are done solely within the IETF, that's publish a draft, sit it on mailing lists, and have people say, no, that's not going to work. Obviously, none of these things work in a vacuum. So this is a place where I think we can also do better, especially as we look at some of the transitions happening in TSV in terms of communicating out to all the stakeholders. This is how this transition is going to happen. This is what we expect to happen. please let us know if this is in keeping with your understanding or if there are gigantic problems which we might fall into. So applying all of this to the TSV area, at about midnight last night, I was like, wow, I need actually a slide to tie all this together, and why are we having this discussion here in TSV? And this is the slide that popped out of that 5 minutes of furious typing. There's 3 that I see right now that are transitions. We'll start with MPTCP. This one is the farthest along of the newer ones, or the older ones. The incentives here are relatively simple because it's purely end-to-end, at least until you start talking about proxies. And I think one of the reasons that the discussion in the MPTCP working group has been so spirited about proxies is because we've now gotten from the point where the transition plan has been something that's relatively simple, just put it on both the endpoints and it works, to relatively complicated. At the same time, a lot of the design work, the initial design work in MPTCP in the experiment was working around these middle boxes on path that were giving the protocol a different experience than the idealized end-to-end model would suggest. ECN was a failed transition that is starting to succeed. I've given this talk like 20 times, so I'll just rattle it off from memory. Published in 2000, people started deploying it, routers started rebooting. People turned it off because they didn't like their routers rebooting. People wrote a lot of blog posts about how you should never, ever, ever turn this on, and you should probably strip it at the edge of your network because it might make your routers reboot. In the meantime, the router people were like, oh, you can send a single magic packet to my router and reboot it. That sounds like a security issue. We should probably get a patch for that. But the operational practice, the state of operational practice stayed, this is dangerous, don't do it. There was a, do you have a, I mean, this is a discussion, so jump in.
I have a comment about, like, something to add to ECN.
Okay, at the end or right now?
Yeah, well, to ECN, so I mean, at the end of ECN.
Okay, at the end of ECN. In the meantime, the Linux network developers decided to turn it on the server side by default. And people kept upgrading their Linux boxes, and then we went from 10% of the top million web servers supporting it to 20 to 30 to 50 to we're at 74 the last time I measured it. Once it hit that point, and once all of the boxes that would reboot when you passed ECN past them kind of worked their way out of the network, it became safe enough to turn it on by default. Apple has done that, and we're beginning to see quite a bit of actual ECT0 marked traffic on the internet. What we're not seeing yet is a lot of CE mark traffic because this was a chicken and egg problem, right? The router vendors weren't going to support marking, the operators weren't going to turn it on if there was no ECT0 marked traffic. There's no wind turning it on at all. And this is essentially the endpoints conjuring an egg out of nothing so that there is an incentive to create a chicken. Does that work? Yes. And the development's ongoing here, right? So we've kind of taken ECT0 back, and then just in yesterday or the day before in TSVWG, we hummed to reclaim ECT1 and hand it to L4S, because also the measurements that were showing that this was working have also shown that that's relatively undangerous as well. We shall see in that experiment how good those measurements were.
Michael Wessel, I believe that a part of the ECM problem also was the fact that if you used it as it was, the benefits were not very clear. So even if even if it did get marked, I think a part was maybe missing documentation about it. So I think Stuart Cheshire helped us a little bit when he presented about head of line blocking getting away when you have ECN. And well, nobody will be surprised when I say that I think that this A proposal that we're having also helps a little bit in that direction, because it's just a simple change on one side that can fix incentives.
Good point.
Maybe I'll wait after Quick.
Oh, okay. So Quick is actually, I think, will turn into an example of how to do the transition planning correctly. I hope we have a chance to do so. It's replacing TCP for some applications, and the plan is essentially indefinite coexistence with TCP because there's not a whole lot of a lever for reducing UDP blocking, which, depending on whose numbers you use and where they measured, comes to around order of 5% of paths in the internet. This plan for indefinite coexistence with TCP is the reason that it replaces TCP for some applications. It replaces TCP for those applications which can use its benefits while also being able to fall back to TCP. HTTP2 is the first of these. And then there will be a discussion of sort of the interplay between the protocol design and this UDP impairment, sort of the state of the network that'll take place within the working group. But I mean, so this is just starting up, so it's very difficult to say much about the transition plan.
Well, no, actually, it works 94% of the time, right?
Yeah.
One interesting observation one thing that came to mind is that there's no guarantee that 94% might not actually go down.
Right.
Because like when we think of a transition plan, we think of something that kind of mostly moves monotonically. But in practice, there are people, because Quick has built-in security, there are incentives against letting it work. And so maybe there's a lesson there. I don't know, but it's certainly interesting, right? That it may go down until something else changes, and it'll go up again. But it is an excellent. So if you look at Quick versus, let's say, IPv6, you've got way more deployment way earlier in the design phase, right? This is still actually iterating, and IPv6 was done and it got deployed 10 years later. So it's way better. And I think the lesson from this is Quick is not a transition. It is indistinguishable, pretty much, from. It's like totally opaque. And like the person, one of the people who designed it, he said basically there's one port on the internet and it's 443. It's the only port that you will ever be able to use anymore. And what that tells me is, do not ever design a replacement. Design something that looks like the thing that everybody thinks they understand. And so while that might seem depressing, right? The only real sort of problems are essentially, MTU problems, right? So,
well, but you're going to have those MTU problems no matter what, anyway, right?
Right. And so basically, so it take DNS over HTTP. What does it do? It does SNI, and then either you block the whole transaction, or you can evolve it in a way that's sort of not end to end, right? So I think that's really important. We can't replace anything anymore. We have to sort of essentially Trojan it almost, to do both things.
So I will remember this 25 years from now when everything has adapted to Quick, and then the only way that we can change things is by piggybacking it over something that has the right Quick version number on UDP port 443. Eventually, we're going to run out of. Eventually, we're going to run out of MTU, but by then there'll be jumbo frames everywhere, right?
I mean, a little bird told me once that some quick release had to get rolled back because some firewall operator broke already. And so, that's kind of depressing, right?
Well, so it's like if you're 443 and then you're a particular Quick version number, it can be like turtles all the way down, right?
Yeah. So I want to actually take the depressing number, or the depressing sort of side of that control loop, and do the non-depressing side of it. It's like, yes, it's absolutely reactive. That's a really good point. Because yes, it may be that people will say, ooh, that's encrypted, and I don't like encryption because I have various policy reasons to not like encryption. So I'm going to block it. Yeah. Right, yeah. Well, my policy reason, if I can't classify it, then I'm going to drop it, right? Right. But there have also been, so I think Ian showed some slides a couple of meetings ago showing that they saw a particular kind of UDP throttling go away because they're like, oh, this is Quick. People are going to complain if it doesn't work. Perhaps we should turn that off.
Yeah, Kulevin, I wanted to make a similar comment. I'm wondering if these things are actually transitions or just deploying new features. And the big difference might be that in a transition, and probably IPv4, IPv6 transition might be the only example, we would all wish that the old technology go away. Maybe that never happens, but in this case, that's not the plan. I mean, would like to keep the old technology as well.
Well, I mean, you keep the old technology, but you hope everyone uses the new one, right? So you hope that so MPTCP.
Still like TCP, sorry.
MPTCP,
It's really easy to use.
Yeah. Yeah.
No, I think there are also use cases where you just don't want to use Quick, you want to use TCP or a different protocol.
Right. Or you hope, so it's basically like another transition that went relatively well was the pre-SAC world to the SAC world, right? Now pretty much SAC OK passes through most metal boxes and you get SACs from most stacks. And for the most part, you know, loss recovery works a little bit better. Rack is another one of these things, and Rack deploys really simply because it's a single endpoint sort of thing. And then I think we've also learned in terms of transitions in transport that you do have to think about these things, like looking at the way that L4S is designed, for example. So a little of this is like, hey, you guys, you should do this. Keep up the good work.
So I think my point is that maybe not all of the transition points on the previous slide apply to something where you don't want to replace the old technology. And I have, now the slides went away.
That's fine.
Yeah, and I have a second comment on MPTCP, because you actually said this correctly. The initial transition strategy was easy, like you only have to deploy it at the endpoints, and that's what we want to do. And then we figured out actually endpoints are not adapting this as quickly as we thought, because not all of the endpoints have multiple interface and so on. There are multiple reasons it's not easy. So they're starting putting proxies in there, which probably helps deployment in the sense that it gets more use. It doesn't help deployment on the endpoints, that what we are actually hoping for. And now we should probably not forget to have a transition plan back to the place where we can get the proxies out of the network again. I'm not sure if we even thought about that, and if that is something also to go here in the document, or like even how to generalize this thing.
Right, how to transition away from a transition technology. That's actually that's an interesting point.
It seems to be like some kind of intermediate step, and you should not have lose the goal where you want to go.
Right. Yep. Oh no, that's wrong area.
BGP was a hack.
Go ahead.
No. If you're continuing conversation, correct.
Well, I'm not, maybe not necessarily, but when we're dealing with impairments, right, I think the blockage changes dramatically in type. So I'll give an example, right? We have this thing called quick. Now, we started off, it worked some percentage of the time. And now we observe that it's slowly getting better, 94, 93, right? But what we don't know is what those numbers would look like if we tried to introduce new features in it. So here's an example. What we're trying to, like, what Quick has the ability to do is to do 0 RTT reconnect and seamlessly resume a session from a different IP address. Now, my personal belief is that we only have a few months, maybe a year, to launch this before it becomes impossible. Because the middle box operators, before it was like, I don't know what this is, I'll pass it, I'll drop it. And now like, I understand what this is, so I'm going to be smart. I was like, oh, a new IP address, same connection ID, security problem. I'm going to protect you from the security. And so suddenly, so maybe the lesson there is, don't make it extensible, make it monolithic. So that in some sense, right? You know, because otherwise, the middle boxes understand it and they'll like basically half break it. And so the failure scenarios that we have to deal with are more complicated. And so, that's something to think about too.
So I think that the crypto gives us an opportunity to make the wire image monolithic. So what you see on the wire when you don't have the keys, while putting the extensibility behind the veil, right? So I think that's an interesting architectural principle, right? You can use crypto as the best kind of must.
I guess the thing that you can use a different IP address is the problem, right? Because that's outside the crypto by definition.
Right.
So that's why. So mobility is a special case.
Right. Okay.
So if you're trying to use a protocol to address shortcomings of the layer below you, right? If you're trying to use Quick to address the shortcomings of IP that it has no mobility, then you can only do that for as long as the middle boxes don't know what's going on.
So if your threat model, I'm making this up as I go along, so this might not make any sense whatsoever. If your threat model is that you have an outer control loop that involves a middle box vendor, then maybe the strategy is to change the wire image quickly enough that as soon as they deploy the thing, it breaks. And it breaks on a thing that was recently deployed so someone can find it.
Chameleon protocol,
Yes.
Yeah, that's good. Yeah, that's
So
good.
at this point, I have a couple of observations. First, we adopted a dual queue mechanism in TSV, but that kind of assumed that there, occasionally we would get to the back queue. So
we try to do arbitration.
Yeah. I know it's like that on the internet too, I'm sure. So that, number two, I would like to say that after what you just said, I've never felt as good about moving from the IB to the ISG.
let's see. I can say a lot of things. Let me see if I can focus on the important ones. Explicit congestion notification may be in transition from what we thought it was to what it's going to be. And I think L4S is a big example. What Michael Wetzel said about ABE, I think also turns out to be another one. At some level, both of those are promising the network that you will get, in some ways, better earlier response to congestion if you don't drop packets. And that provides some incentive to the routers to do it. And that's certainly a change, because when ECN started out, it was a plug-in replacement for drops. And as I think you observed, something was not quite there in the incentives and motivation framework. Also, talk about interesting example of a failed transition, which I think is mentioned in the context of port 443. I'll talk about this in terms of UDP Lite. I've lived through some very interesting times dealing with UDP checksum problems, and people just want to turn it off to solve problems which UDP Lite would be the right solution if it carried UDP's protocol number, but it doesn't. Game over. Now what? And the latest we've got is Joe Touch's clever hack to possibly hide something between the end of the UDP packet and the end of the IP packet to tell you the checksum coverage is incomplete. I sure hope this works, but it's an interesting example where we ossified around something else.
So I'm a big fan of that hack too, but I as somebody writing who has done sort of like automated verification of security bugs in implementations of things, this is one where the compliant thing is a security bug, right? It's a bounds checking error, and we're going to just run a bounds checking error. It's cool, and I hope it works, but to some extent I hope it doesn't.
As I said, it's definitely a clever hack if it works, because if we had UDP Lite, we wouldn't have had the horrendous discussions about turning off UDP checksums for IPv6.
Right.
Usually within 5 feet of David Black.
Mega cool event. So just as we started talking about one of our favorite topic, middle boxes, I thought that actually layering might help us. If you can separately, nicely, who needs to know what and who needs to do which action, and not try to mix everything up, that can be something that's very helpful in transition.
Yep.
Cool.
So that's what I mean, that's what I think I'm getting at with the wire image concept, right? What you can see versus what you can. And that becomes kind of a new layer in the architecture itself, that boundary.
Hi, Colin Perkins. So following up a little bit on the previous comments on ECN. In some ways, it may be that what we're seeing is a recognition of what the operators want to do already, and that the operators don't want to drop packets, and we finally designed a protocol that enables them not to and rewards them for doing what they want to do. I also I wonder if the L4S stuff, which I think is very cool technically, runs the risk of muddying things from the, well, it's not safe to turn ECN on or now because it's still changing. And we need to be careful about that sort of thing and the messaging we're giving.
Especially in light of Michael's previous comment that it was the messaging was mixed about what you would get if you turned ECN on, because we didn't really know. And we didn't do a good job of communicating that. Now we have a better idea and we've done a better job of communicating. But yeah, I think there is a work item for us to make sure that we are very clear about the impact of L4S on ECN.
Yes. In some ways, calling it something which doesn't involve the letters EC and N anywhere may be a good idea.
How about L4S?
Learns a lead.
Oh, yep. It's a new redefine the name of the code point. The former ECT1 code point. That's interesting.
To go back to what I thinking more about what I said before, I think about the ability to evolve once you've launched a protocol. I think in some cases, if you have something that could provide additional benefit to the users of the protocol, you have to be careful not to. You have to like launch it at the same time as the protocol itself to take advantage of this of the fact that this like naive blocking just blocks.
Back to the curves.
Yeah, but
you want to put a bump in one of the green curves.
You can't.
Yeah.
Right. You can't put the bump in the curve because like this mobility thing, right? If you wait too long, it's just not going to be possible anymore.
Right.
So ideally, if you can announce it to customers or users quickly, and then maybe you have a chance of lessening that smart middle box trying to block it. And so you have to be quick about it.
So Spencer Dawkins speaking as AD for just a second. I've got an alarm running back there that's going to end about 8 minutes before the end of the session.
Okay.
We wanted to make sure you had an opportunity to have the last word, and we wanted to give you an opportunity to ask us to be thinking about anything that would be helpful for us to be thinking about. So you can make us do work if you'd like to do that. But that will be, after the alarm goes off, that will be your time. Now back to being a curious transport guy. And not an AD. You all were talking about transitioning away from transition mechanisms, and I thought the note that I had made before that was about, it sounded worse, how you coexist with a coexistence mechanism. So like, now you've got 3 of them, and lather, rinse, repeat for as many of them as you'd like. This is again one of the points where I'm glad I'm on the ISG and not on the IEB. But I wonder if the IEB is thinking about that in those kind of time frames.
So in this particular document, we don't address it. We probably should, because any multiplexed transition mechanism is one that the endpoint implementations then have to pay attention to, right? So I'm thinking back to the MPTCP thing. It's like, okay, I have multiple interfaces. I also can discover an MPTCP proxy. Do I get, so I'm a phone, I have an LTE interface. I'm on a network where the CPE is connected to a different LTE network, and I'm connected to it over Wi-Fi, and it also has DSL, right? So I have 3 paths, 2 of which I can get to via one proxy, and 1 of which I can. So is this a situation where I should actually build something into the protocol to discover and interact with that? I'm probably going to have to build something into the protocol to discover the proxy anyway, so I might as well use it, use knowledge that I can get of it in order to do things. But then you get into another turtles all the way down situation, right? And you get into another, another situation where you've added a whole bunch of code paths to the endpoint to work around something that will hopefully go away at some point in the future, but those code paths aren't going to go away because they work until someone exploits them.
Martin Duke. When we're talking about incentives for various people to adopt these protocols, I think quite interestingly, I'm not sure that endpoints are actually an important stakeholder in this.
Yep.
Just because, I mean, from your ECN story, for the clients and servers, you're saying, well, all these operating systems are turning on by default. I mean, it's not a story of data center operators and end users at the office saying, I need ECN. It's convincing operating system implementers that it was a good thing to do.
And they're sort of, the reason that Apple decided to do it is they did their own testing and said, we can get better user experience if we do this, right? So it was the endpoint vendor who said, so I don't actually know why the decision was made to put it in the Linux kernel. It was probably like, this looks cool, I'll implement it, and the patch got accepted, right? I mean, that's the Linux.
Well, it's not so much adding it to the kernel, it's turning on by default. That's the key decision, because most people are not TCP tuning experts. Yeah.
And there was actually one particular problem with ECN in particular, where we were talking to some of the kernel devs who owned that bit of code about, hey, how about you make ECN 3168 fallback work? So the way that 3168 says you're supposed to do ECN is you send this in with trying to negotiate ECN. If that doesn't work, then you fall back to not using ECN and you remember that you did that. And that hadn't been implemented in Linux. It would just keep sending sends with ECN, and if they were blocked, then you would have connectivity failure. So we talked to them and we went back and forth and back and forth and back and forth. And one of the developers was like, I don't really even understand what's going on here. This is just completely broken. When I turn this on, just horrible things happen to my internet connectivity. Because he happened to be on the one network that we were able to find. So we found it, we talked to them, and then Apple found it, and then Apple talked to them, and Apple was bigger, so they listened to Apple. That was basically messing with ECN signaling due to a bug in how they'd done their QoS inside their network. They were leaking ECN marks outside their network, and it was just breaking stuff, right? So the congestion window would always reduce to 1. It took a while to convince him because it's like this little tiny cable operator in Germany, and that was his residential operator. And we're like, you should totally use ECN. It's awesome. And he's like, it breaks everything. I'm not applying the patch. So I guess the lesson from that is that local conditions can also affect people's willingness to help you in a transition.
So this is Spencer Dawkins, switching back to maybe an AD hat again. So I was around when NATs were deployed in the first place, and when people one of the objections to IPv6 was, well, I have to, basically by the time that was a realistic thing to deploy, then you had all these auditors with audit checklists for network security that says, do you have a NAT? Not do you need a NAT, but do you have a NAT? And so I think that's a good example of the impact of operational practices on our ability to evolve the internet and to do transitions and get past coexistence and things like that.
That's if I can jump in there, that's a really good point, because you have sort of the same thing with certain compliance regimes that where TLS is A-OK and anything that's not TLS is not A-OK. And I think that impacted some of the decision to move quick over to TLS 1.3, I believe. I think other than the NAT thing, that in transport we're relatively safe from compliance level meddling, but I'm not sure.
And so when you go crawling back to the IAB, there's no place to hide, right?
Yeah.
So I guess a thing I would suggest is I would love to dump this all on you guys as something to work on, but I think this is something we should probably be talking to between the IAB and IESG on how we can get a better handle on what practices are out there and what the impacts of those things are going to be.
Yep.
Thank you.
Yep, thank you.
So you've actually given us work already.
Yay!
And the alarm hasn't gone off yet. Good job.
Matt Ford. It's sort of following on from the point about endpoints not necessarily being relevant. One of the things you might want to consider is, although it's, I think, generally a valid point that, flag days are impractical when you're thinking about the whole internet, all the endpoints on the internet, they can be of some use when you're thinking about smaller constituencies. So I'm thinking particularly of our experience with World IPv6 launch, where if you can identify some key actors, and they can agree to jump off the cliff at the same time, they can bring a lot of the internet with them.
Yep.
Either at that time or soon thereafter. And it's a similar. It's also it's not exactly the same thing, but we're also seeing similar effects now with the CDN point you made about the Alexa 1 million. It's like centralization of web infrastructure services and web content maybe has its downsides, but maybe when it comes to making stuff change, it's quite helpful.
Fewer phone calls you need to make and fewer people you need to convince. Absolutely.
Yeah. And Janinko, looking at this cost-benefit graph, I think one of the problems with some of the transitions is that benefits are for one players and all costs go into others, right?
Yep.
We saw this is V6.
Yep.
So people who benefit from it, not necessarily, at least currently, people who have to do most of the work. So it's really hard to provide the motivation. And secondly, I think that one critical factor might be a time frame when you actually see this benefit spike.
Mhm.
Because what I've heard from some operators, they just do not care what's going to happen in 10 years.
Right.
People who actually have to do the work, they don't even care. So if you start talking about transitions from which you're going to benefit in 25 years, most of the people just would not do that because they don't care.
Right. Beyond their reporting horizons or their planning horizon. And I think that's actually one of the reasons that all of these things over on the B side are risky, because you don't know when that inflection point is going to hit. And if you're going to be an engineer and you're going to give, what you think is a realistic estimate, you're going to give something that's not going to be very inspiring.
On the subject of timing, Bob Briscoe, it's also important. It's often not just like it's not the end users, it's the operating system developers. Similarly, it's not necessarily the operators. It's sometimes the operators forums, things like the 3GPP or GSMA or whatever. And like the 3GPP has release cycles, and that has a sort of time frame which you have to fit in with. And if you come just after they've just frozen everything, it's sort of just too late. And also what you're doing has to be good enough for what they're going to have done by the end of the time they've done their release. So it has to be, the benefit has to be better than what they were going to do otherwise, at that time. I'm particularly thinking we happen to be at a reasonably right time scale to do sort of beyond 5G, 6G or whatever for L4S. That seems to be, or at least particularly possibly for 5G, where we're in time, and that L4S buzzword seems to be moving around the mobile operators now because they need low latency and all the rest of it.
I wait 3 more seconds if somebody else has a comment. Brian, do you want to try and summarize something, or no, you don't even want to try it?
I really don't. No, this was really interesting. It kind of went everywhere. I'm glad it went everywhere.
So I think
we have a transcript of this, right? Excellent. Thank you, Matt. Oh, that's where you were zoning out over there. Okay, I got it.
But other than that, I think like the base document is in pretty good shape.
Yep. Although there were a few things that I heard today that I'm going to take back to Dave and say we should think about whether this is a general. There's something general to take from this. I heard a few things this was good input for the document. Thank you.
Yeah. Also, I mean, because Dave was not here, maybe everybody who spoke up, please check the minutes and make additions if your point was not captured completely, or if you want to just explain more about your point, you can also choose the Tsvarea mailing list and send your comments there. Or is there a program associated with that?
This is associated with Stack Evolution.
So it's a Stack Evo Discuss
mailing
list. Yeah, so you can send it to
Stack Evo Discuss at IETF.org.
But I mean, as we started a discussion in transport area, you can use the transport area mailing list.
Yeah, because we're talking transport applications, right? That's what you're thinking.
Yeah, because the discussion was quite transport focused here, I believe.
Yeah.
So maybe we can also figure out if there's any specific things we want to keep in mind for transport specifically. And I have one more question for the end. I mean, as I said, it's a nice document. The IAB is working on it. It's in good shape, and hopefully it will be published kind of soon. But what's after it? Will it just be sit there and nobody will read it? Or can we do something in the IETF that this stuff will actually be applied and we can do better in the future?
And so typically the life cycle as it gets published and then nobody reads it.
That would be unfortunate.
That would be unfortunate
case.
for this one.
Yeah. I worked on some drafts at the IB where that might have been best, but this isn't one of them.
No, I mean, like, also ideally people would read this before they start working on this stuff. So
we had at the discussion in Berlin the idea of a transition consideration section in RFCs came up, and it seemed bureaucratic to everyone. And I think I might have even been one of the ones who originally proposed it, and it seems bureaucratic to me. A question on the document shepherds checklist, is there discussion of how this is going to coexist with other things, or how this is going to replace other things, or what the incentives are, right? You don't want to put it all in a section, but you could put a question on the checklist to, okay, that's too bureaucratic for 1, 2. I mean, yeah. So like, how do you take this and transition it to practice? Right? Sounds like somebody needs to do an AD sponsored.
David Black, it's been done already.
Yeah.
I suggest having a look at the ops area checklist. If the ops area does a full review, the reviewer will hit transition and coexistence questions. They're in the question list. I think it's Appendix 5706. I think that's right, RFC.
So the one thing we could do is just basically have the ops tier, like when this document is published, say, hey, everyone in the ops tier who didn't know this was happening, please have a look.
As if the ops folks don't already have enough to do, but in fact, transition is a network operation issue. So that is the right area to locate it. Then we can talk about manpower or womanpower.
Excellent. Thank you, David.
I think you should do a cost-benefit analysis of the goals
of protocol. Yeah.
Colin Pickens, it strikes me that we're very good at producing guidelines and documents, and not so good at advertising them. And
say that again.
And not so good at advertising them.
Okay.
So maybe we should.
10 minutes in plenary.
Well, yes, but also to the wider community.
Okay.
For example, being a professor, I teach networking courses, and I point to some of these documents when I'm doing that sort of teaching, and we're not very good at advertising to that sort of community, and maybe we could get better at that. So maybe
that's very good point.
Off list.
Yep.
Miriam?
Yeah, so even we're talking about protocol transition, which is very technical. I guess we've been talking about a lot of points which are not technical. Just having phone calls, right? The right people have to talk to each other. And having a section in a draft is like, you can do the technical details in there, but you can't say Apple should please call this network operator or whatever. So that's more political, and that's about what Colin just said. That's about outreach and educating people.
I really like that idea because, I mean, so that'll basically have, students who are reading now are going to have an impact on the network 10 years from now, and that's quicker than the IPv6 transition. So
yeah, so get it into the next edition of Tannenbaum's book or Peterson and Davey or whatever.
Let's talk about that off list.
Absolutely.
Let's chase that one down.
Cool. If there is no other business, is there any other business? If there's no other business, I would like to thank Brian for coming here and doing this. I think it's really important for transport area people to be thinking about. I would like to invite Brian to tell Dave Thaler that he would have had much more fun here than going to HomeNet. You've been jabbering him, or he just knows. And I'd like to give everybody probably a 2-minute head start for cookies. Thank you all, and we will see you in scenic Chicago.
Sorry, can I bring an AOB thing up?
Sorry?
Can I bring an AOB thing up to stop people having the head start for cookies? Any other business?
Yes.
No, it's just about AQM working group. You said it's closing. Just presumably you need to say something about where AQM work goes and that sort of thing. Yeah.
I mean, that's what we're still discussing because it's not closed yet. But presumably it will be in a T3 working group because that's working group where, all the other work goes to. The reason why this seems to be closing is because since we had a meeting in Berlin and there was a lot of discussion, but there was actually no real work coming up. There were no new drafts. There was no discussion in the AQM mailing list. So that seems to be, there's not enough energy right now to just keep it open. And as we have this fallback.
We had one gross, so it's one new work.
Yeah. One. But as we have this fallback to T3 working group, and especially for this one work draft, it fits very well with the other drafts we have there. that seems to be the solution to go for.
Yeah, definitely talk to us about work, and we'll make us find where it needs to go. Mary and I are both talking to the chairs of TSVWG about this, so we're not just like launching it in there and waving. But like I say, if we need to do work, we will find a home for it. And if we need to do work and there's a community of people who are willing to do the work, we'll find a home for it.
I sort of knew the answer. I was just getting you to tell everyone because
yeah,
I mean, like as I said, there's still some discussion going on, and I will tell at the end what was decided. But that's the plan so far.
Yeah. Cool.
David Black, one of the TSV chairs. Yeah, we pick up a lot of stuff, and I guess AQM heads our way now. It doesn't have to stay put. I mean, to some extent, TSVWG is this really needs to be done working group, and it would be wonderful to occasionally see things that need to be done during enough enthusiasm that it makes sense to send them off to their own working group, even if they start in TSVWG. We can wish.
Thank you very much. And with that, am I told that this is not a cookie break? It's only a drink break. So. TSV, go forward and drink.
Thank you.
See you in Chicago. Thank you so much for your help with this. I mean, this was terrific.
I was a little bit afraid that we wouldn't fill the time, but it was really.
Well, I mean, having and by